Hello everyone, I am Namrata Maditripathi from IIT ISM Dhanbad. Uh, this is a problem solving session for the course Differential Equation for Engineering. This is problem solving section week 9 in which we will discuss the problem related to the lecture series week 9. These are the questions which we will discuss in this session. You can try to solve and give me the answer. The questions are related to wave equation and their solutions which we have to calculate. Okay, let's start from question number 1. The question says find the solution of the initial value problem. You can see the problem. This is wave equation with given initial condition. Please note down the question and try to solve. Okay, let's start question number 1. Here x is belong to real number and t is greater than 0. These conditions are given and the initial condition are x sin x and ut x comma 0 cos of 2x. Here x belongs to R and x belongs to R. Can anyone tell me how to solve this question? For x belongs to R, which formula we can use? We have learned in your lecture series the form of wave equations when x belongs to R, when x greater than 0. Okay, I'm going to write first of all the formula for this condition when x belongs to R. These are the initial condition. In this condition, the solution given by this is D'Alembert formula. The solution is known as D'Alembert, where x belongs to R, t greater than 0. Now you have to apply this formula on this question. What is f? F of x is x sin x and g of x is cos of 2x. Now you have to simply put the values. What is c? C square is 3, so the value of c is under root 3. F of x is x sin x. So f of x minus t means x minus ct means x minus under root 3t sine of x minus under root 3t plus x plus under root 3t sine of x plus under root 3t. What is g of x? G of x is cos of 2x. 1 upon 2c. C is under root 3. The limit is from x minus ct, x plus ct, g of s, or you can take any variable u. I am taking here. Now you can simplify. First expression you can leave as it is. And the second expression, after integrating, this will become sine of 2u upon 2. So this will give 4 under root 3 sine of, if we put the upper limit, so this is the value of u of x comma t. Is it clear? Is there any doubt in this question?
Ma'am, C means root 3, yeah?
Yes.
So UTT minus 3 UXX is given, so that C squared is equal to 3 or C is equal to root 3. Is it, ma'am?
Yes. Yes.
Okay.
So the question 1 is completed, in which we use the condition Okay, let's move to the next question. Question number second. The question second is find the solution initial boundary value problem. This is also a wave equation where x is greater than 0 and t is greater than 0 with given initial condition ux comma 0 is sine squared x and ut of x comma 0 is 0. This is the initial condition including boundary condition. So here the value of x is positive. So you have done for the x real number and x when x is positive. Uh, what the expression for the solution we can use in this question? Can anyone tell me? This is wave equation where x is greater than 0 or you can say belongs to 0 to infinity. T greater than 0, initial condition with boundary condition also. This is also initial condition. What is boundary condition? 0 comma t when t greater than 0, or you can say u x0 comma t. The difference is this is fixed age and this is free age. Fine. So the solution for this type of wave equation is given by this is the solution for this type of wave equation. Now in our case in the given question, the f of x is sine square x, c is 2, and g of x is 0. So you can put
Ma'am, in the second term,
yes.
integral of function is not written.
Oh,
Ex-
sorry. This is g of s, d of s. Thank you. What is f of x? Sine square x. So sine square x plus c is 2t minus sine square x minus 2t. When x is from 0 to ct means 2t, and because g of x is 0, so the second term will be 0. So this is the solution. Okay, next question. Is there any doubt in this question?
what is the integral of g of s?
G of x is 0, so g of s will be 0. So the second term will terminate it.
Okay, okay.
Okay. Okay, let's move to the next question. Okay, next question. First of all, you have to try because this is similar to the previous one. The question is find the solution of the initial boundary value problem. U of x0 is sine of x and ut of x comma 0 is x square. This is the initial condition. Boundary condition is 0 comma t. Now please solve. What will be the solution? One by two f of x plus ct minus f of ct minus x plus 1 by 2c ct minus x plus ct g of s d of s. When x is from 0 to ct and 1 by 2 f of x plus ct plus f of x minus ct plus 1 by 2c x minus ct2 x plus ct g of s d of s, where x is greater than ct. So this is the solution. Now we have to use f of x is in this question sine of x and g of x is x square. So simply you have to substitute these two values and you can find the solution. After substituting, you will get f of x plus ct is
2t.
sine of x plus ct 2t plus x, fine, minus f of x minus ct minus x means sine of 2t minus x plus 1 by 2c means 1 by 4 integration of ct minus x 2t minus x and x plus 2t. G of x is x square, so we can write as okay. Firstly we can calculate this term. You can use sin c minus sin d, or you can leave as it is. This will become sin sq upon 3. So after substituting the upper limit, x plus 2t whole q upon 3 minus 2t minus x whole q upon 3. When x is from 0 to 2t, and the next expression is when x greater than 2t, one upon 2 f of x plus ct x plus ct sorry plus f of x minus ct plus 1 by 4 again integration of g of s ds means integration of x s square, so you will get x cube by 3. After substituting the upper limit and lower limit, you will get x plus 2t whole cube upon 3 minus x minus 2t whole cube upon 3. This is when x greater than 0, and this is when x from 0 to 2t. Fine. So this is the solution. Sorry, this is t. Okay, is there any doubt in this question? Simply you have to use the D'Alembert formula. You have to find which formula we have to use, because there is difference when x greater than 0 and when x belongs to real number r. Accordingly, you have to use the formula, then you will get the answer.
Is it only two cases, ma'am?
Yes, basically it is two cases, when x is belong to real number and when x is positive.
Okay.
Okay, so next question is quite similar. You have to just find the solution. So this is initial condition and this is boundary condition. Now please try to solve and give me the answer. Is anyone trying to solve?
So it is a case 2. Uh,
Yes,
1 by 2 cos of pi of x plus t by 2 minus cos of pi of x minus t by 2. C value is 1.
yes. So in the first case, second case, there are two solutions when x is from 0 to t and x is greater than t. So are you saying when x is from
Yes,
0 to t?
yeah, yeah.
Okay, okay.
0 to 0 to t.
Anyone else? Simply you have to use the formula and you can put the value, you will get the expression.
Here g of s is 0.
Yes. g of x is 0. U of x comma t in this case is given by, first, when x is from 0 to 2t, sorry, 0 to t, because c is 1. F of x plus ct means cos of pi by 2 x plus ct means x plus t minus cos of pi by 2 ct minus x means t minus x plus this expression will become 0. Another expression is f of x plus ct means cos of pi by 2 x plus t
plus cos
plus,
of pi by 2 of x minus t.
yes, plus here 0. Fine.
Yes, ma'am.
Okay. Okay, the next question is, consider the PD where x is belongs to R and t greater than 0, where alpha beta belongs to such that lambda square plus alpha lambda plus beta is equals to 0, has two distinct roots c1 c2 from real number, then use the transformation variables xi x plus c1t and eta x plus c2t to reduce the above PD. Okay, please solve uh, this question.
Ma'am, is it the normal equation? R-
Yes,
Reduce?
you have to reduce into the normal equation
Yeah.
using the transformation. So, how to reduce?
So first, can we consider b squared minus 4ac? Either
See,
it is a parabola, hyperbola, or Laplace equation.
okay, you can check this is hyperbola, parabola, or but no need to no need to check here. You have to just reduce the given PD. So you have to find UTT, UTX, UXX in the form of xi and eta. So you have to use first of all you have to find UT in the form of xi eta. Then by using chain rule, of course.
Okay.
Can anyone tell me what will be the value of UT? Means del U upon del T, because I have already discussed this in previous lecture also. U is a function of T and X, and T and X is function of xi and eta, we can say. So you have to apply chain rule.
Can we first evaluate ux, ut,
Of course,
uxx?
you can evaluate UX also, UT also, as you wish. First of all, tell me the value of alpha and beta. How to find alpha beta? There is a given equation which has distinct roots C1, C2. By using the sum of roots and product of roots, you will get the value of alpha beta.
C1 plus C2 equals minus alpha.
Yes. So alpha will become minus of C1 plus C2, and beta will be C1 into C2. Okay, fine. Now tell me the value of UT.
Ma'am, how to get that alpha and beta value? Can you please explain?
Okay, we have given lambda square alpha lambda plus beta is equals to 0 has two roots C1 and C2. What will be the formula for sum of the roots? Have you learned about quadratic equation?
Yes, ma'am.
Square plus b of x plus c. If c1 c2 will be root, then sum of the root will be minus b by a, and product of roots will be c by a. So here b is alpha upon 1, and c1 into c2 will be c by a, means beta upon 1. Fine.
Okay, ma'am.
Okay. Now tell me the value of u of t. How to find u of t? If u is function of xi eta and xi is a function of dx and eta is function of xt, what will be the value of u of t?
U xi t plus u eta eta t.
U xi t plus u eta t. Yes,
Xi t plus u eta eta t.
yes, yes. U of t means u of xi and xi of t plus u of eta of t by using chain rule. Fine. Is there any doubt?
No, ma'am.
Okay. Now tell me the value of utt. Again, you have to differentiate ut. Because I have already discussed, so you have to tell me the value of utt also.
Xi t square u xi plus 2 xi t eta t u xi eta plus eta t square u eta eta.
Okay, okay, fine. And you can put the value of xi t and eta t. Because, okay, what will be the value of xi t and eta t? Because xi is x plus c1. Okay, let me write ut first in the form of, since xi is, what is the value of xi? X plus c1t and eta is x plus c2t. So xi of t will give c1 and eta of t will give c2. So u of t will become c1 u xi plus c2 u eta. Fine. Now the value of utt means, first of all you have to integrate with respect to xi, u of t and u of eta. Fine. You can substitute the value of ut here from above expression. Then you will get c1 u xi plus c2 u of eta into xi of t plus c1 u xi plus c2 u eta of t. You can put the value of xi t and eta t. Xi t is c1, eta t is c2. And after differentiating partially with respect to eta, you will get c1 u xi plus c2 u xi eta or eta xi. Both will be same because these are continuous solution. and this is C2. Fine. C1 square u xi xi plus sum of these two C1 C2 u xi eta plus C2 square u eta eta. So this is the value of UTT. Fine.
So we may use formula also, no, ma'am.
Yes, you can use directly formula, or you can substitute by step. You can evaluate also.
Okay.
Now, what will be the value of u of x? Can anyone tell me? Again, u xi
Use
x plus u
plus
eta x, and xi x is 1, eta x is also 1. So this will become fine. Now, what will be the value of uxt?
xi x xi t u xi xi plus xi x eta t plus eta x zt into u xi eta plus eta x eta t u eta eta.
Okay, are you telling the formula?
Yes, ma'am.
Okay. You can go through the formula, or you can just, if you don't remember the formula, then you can use chain rule. You have to differentiate ux with respect to t. So first of all, we differentiate with respect to xi and xi of t. Fine. And also with respect to eta, u xi plus u eta of t. Fine. This is C1, this is C2. C1 u xi xi plus C1 u eta xi C2 u xi eta plus C2 u eta eta. Fine. Because these are equal. Now, please tell me the value of uxx. You have to differentiate this with respect to x again using chain rule, or you can use the formula if you have remember. Tell me the answer. What is the value of uxx? Okay. Again, you have to differentiate ux with respect to x, means first we will differentiate with respect to xi and xi with respect to x. Fine. Again, with respect to eta and del eta upon del x. Xi of x is since xi is x plus c1t and eta is x plus c2t, then the value of del xi upon del x is 1 and this is also 1. So okay, now the given PD is UTT plus alpha UT of x plus beta U of xx is equals to 0, where x from real number, t is greater than 0. Now you have to substitute the value of UTT, UTX, UXX. Fine. What is the value of UTT? UTT is C1 square U xi xi plus 2C1 C2 xi eta plus C2 square U eta eta. What is the value of UT of x or UXT? Both are the same. Alpha. What is the value of alpha? Minus C1 plus C2. Fine. And UTX is C1. Wait. This is bracket. This is the value of UTX. plus beta. Beta means C1 plus C1 into C2. Fine. And u of x-axis here. Now we have to solve this expression. What will be the value of minus 2 C1 square u xi xi? This is not uh, here. Because the expression is alpha utx. So after multiplying you will get minus C1 square u xi xi minus C1 C2 u xi xi and minus C2 square u eta eta minus C1 C2 u eta eta, and after multiplying this and this term you will get C1 square C2 square plus 2 C1 C2 u xi eta. Fine. This will cancel out. Okay. Just wait. Okay, after simplifying you will get the expression you can solve, then you will get the expression like this, and this is equal to 0. This is equal to 0. Since C1 and C2 are not equal, because in the question C1 and C2 are distinct roots, that imply u xi eta is equals to 0, which we have to prove. Is there any doubt in this question? Is that clear?
Okay, ma'am.
Okay, if there is no doubt, we can move to the next question. Question number 6. Question is find the solution of the PD. Again, the same equation is given. Has two distinct roots with initial condition. So in this question, we have to find the solution for the PD. This there are the given condition which are similar to the previous one. The PD is also similar to the previous question. So please try to solve. How to solve this question? Can anyone tell me how to proceed? You can directly use the previous question and you can reduce the given PD into canonical form. Okay, as we have shown, in problem 5, for given such alpha beta, the PD can be equivalently written as u xi eta means it is function of xi eta is equals to 0. What is xi eta? Xi is x plus ct c1t, and where xi1 is, sorry, xi is, where xi is, and eta is x plus c2t. Fine. So can anyone tell me what is the value of u xi eta from here? What will be the value of u xi eta? Simply you have to integrate with respect to xi, and you with respect to eta you will get the solution. From here, what will be the value of u xi eta? Let's say some function phi1 xi. When you will integrate with respect to xi, then eta will constant, and when you will integrate with respect to eta, xi will be the constant. So you will get this expression u xi eta. Fine. Is it clear?
Okay.
Okay, now you can substitute the value of xi in eta. So you will get the uxt in terms of x and t. In terms of what will be the value? X plus c1t plus phi 2 x plus c2t. Okay, with initial conditions such that, what is the given initial condition? Ux comma 0 is f of x, and ut x comma 0 g of x. Fine. Ut x comma 0. Okay. Okay, now using this condition, okay, let's say second one we will write up later. After using this, you will get, put the value of t is equals to 0, then f of ux comma 0 is f of x, and phi 1 x plus phi 2x. Fine. After applying this initial condition, you will get the expression. Let's say this is equation 1. And now the second condition is, means you have to differentiate this expression. Let's say this is equation 1, this is 2. you have to differentiate equation 1 with respect to t, and then you can apply the condition. Fine. Differentiate equation number 1 with respect to t and tell me the answer. As we get equation 2, similarly you have to find the expression.
Gx equals C1 phi 1 dash x plus C2 phi 2 dash x.
Okay, g of x is c1 phi 1x plus c2 phi 2x. Yes.
Phi 1 dash x.
Dash means with respect to x, isn't it?
Yes, yes, yes,
Yes.
yes.
Okay. So you have to differentiate equation 1 with respect to x. Since phi 1 is function of x plus c1t, so can we implies the second condition phi 1 x plus c1t with respect to x plus c1t, and with respect to t, and after this you have to substitute t is equals to 0, and second phi 2 x plus c2t with respect to x plus c2t into, okay, let me write into with respect to t, and after evaluating you have to substitute t is equals to 0, and the value of ut x comma 0 is g of x. Are you getting? So after substituting t is equals to 0, this will become 0, this will become 0, then you will get phi 1 with respect to x. Fine. And if you differentiate with respect to t, you will get c1, and second expression you will get c2 phi 2x is equals to g of x, where x belongs to R. Fine. Is there any doubt? So our goal is we have to find the solution ux comma t, uh, which is function of phi 1 x plus c1t and phi 2. So we have to calculate phi 1 and phi 2, then we can substitute, then we can get the value of ux comma t. Fine. We have two equation 1 and 2, and we have to find the value of phi 1 and phi 2, but here the phi 1 and phi 2 are partial derivative. So can we integrate? Okay, after integrating with respect to x, you will get from x naught to x, let's say. Here can we write some s d of s c1 phi 1 s d of s. Fine. After integrating, you will get phi 1 of x upper limit and minus phi 1 x naught. Similarly here phi 2 x and minus phi 2 of x naught. Let's say equation, this is not equation 2, let's say this is equation 2. So you have two equation, two unknown phi 1 phi 2. You can calculate from these two equation, then you can get the value of phi 1 and phi 2. Please try to calculate the value of phi 1 and phi 2 from these two equation. Equation 2 and equation 3. Tell me the answer. From equation 2 and 3, sorry, this is 2 and 3. And C1 phi 1 of x is equals to x naught. Fine. So can we multiply with C1 and we can subtract from this to this, then you will get phi 2. Similarly, you can multiply C2 and after subtracting you will get another expression for phi 1. This will cancel out. You will get C2 minus C1 minus C1 f of x plus fine. So the value of phi 2 of x is 1 upon C2 minus C1 fine. Now you have to calculate the, similarly you have to calculate the value of phi 1. Again you can multiply with C2 and you can subtract. What will be the expression of phi 1 of x? Tell me. Similarly, you can solve for phi 1. Just you have to subtract from this to this after multiplying C2 in this expression. Then you will cancel out phi 2. So the expression you will get in the second term will remaining same. Now the expression for u x comma t is phi 1 x plus c1 t plus phi 2 x plus c2 t. Okay, so at the place of x you have to replace with x plus c1 t, and similarly in phi 2 of x the expression x will replace with x plus c2, and you have to add these two expressions, then you will get the value of ux comma t. Phi 1 is 1 upon c1 minus c2 minus c2 f of x, means x plus c1 t, plus and the expression for so this become x plus c1 t, and the expression for phi 2 is f of x is x plus c2 t. Here x plus c2 t. Phi 1 x naught plus c2 phi 2 x naught. Fine. So here the expression is c2 minus c1, sorry. After multiplying you can write as ux comma t as c2 upon c1, just wait, here minus is there, so this will give c1 minus c2 or c2 minus c1. Okay, this is c1. uh, This is C1 and this is C2. If we write this expression first and the second expression, fine. And after multiplying this term with these two and this term with these two, these will cancel out because here C2 minus C1 and here C1 minus C2. So these two term will cancel out after taking minus. You will get 1 upon C2 minus C1 with negative expression. So we can cancel out these two terms. So rest of the term will remaining term this and this. The remaining terms are plus 1 upon C1 minus C2 x naught x plus C1t g of s d of s plus C2 minus C1 x naught x plus C2t d of s g of s d of s, where t greater than 0, x belongs to R. So this is the general solution. Now tell me if there is any doubt in this question. If there is any doubt, you can ask.
Hello, ma'am.
Yes.
Ma'am, in the first type of problem, like find the solution of initial value problem or initial boundary value problem.
Yes.
If x belongs to closed interval 0, L is given, t is positive and L is positive, then there will be four initial conditions are given. U of 0t is equal to 0, ut of L comma t is equal to 0, u of x comma 0 is equal to some function is given, a into sine pi x by L, ut of x comma 0 is equal to 0. So how to solve this type of function, madam?
Uh, so are you talking about the when x is from some a to b?
Yeah.
Okay.
Yeah.
So if problem is like this, if wave equation with condition x is from a to b, then you have to go through the uh, variable separable method, general method. You have to apply general method in this case and apply initial condition and boundary condition. You will get the expression. Have you learned about separable of variable method to find the ux comma t in
No,
your
ma'am.
lecture series?
No, ma'am.
Uh, Please go through the lecture series in which you have explained the process when the value of x is fixed from a to b, some constant a to b. Then you have to apply the variable separable method, and you can substitute, and after applying the condition you will get the answer.
But I think will be there in the week lecture. But this is the ninth week assignment questions.
Yes, this is have you done these lectures wave equations?
Yeah, wave equation has done,
Okay.
but this part is not there in the ninth week. Variable separable is not there in the ninth week.
Okay.
Questions.
Let me explain.
Can I share? Can I able to share?
Okay, you can share.
I will try now. 1 minute. Is it visible, ma'am?
Yes.
First question, find the solution of the initial value problem. Utt minus c square root of xx is equal to 0. X belongs to
Yes, yes.
t is
So, this type of problem, you can go through the general method.
okay.
You have to use like variable separable.
Can you
Ux to uxt, you can consider some x, capital X, which is function of x only, and t, which is function of t only. Then you can find utt, uxx, you can substitute, and after applying these given boundary condition and initial condition, you will get the expression for ux comma t.
can you able to show one example, ma'am?
uh, okay. I haven't any example, but I can give you the idea. Let me try.
Okay, ma'am.
So let me write first how to find an axis from some a to b. Fine. In this case, you have to use separation of variable. For this, you can consider which is not equals to 0 as a solution. Okay. Now you can calculate the value of utt, which will give x of x, and another one is uxx. After substituting in your expression in the wave equation, you will get the expression like this. I will learn about this separation of variable method in your lecture series.
Not a,
Okay, okay. Maybe after week 9, you will get the this method how to proceed. Now you can divide with x of x and t of x, because this expression is not equals to 0. Then you will get t of x will cancel out. and or you can write, or you can take this into denominator. We can consider this as lambda constant, and after taking this with this expression, you will get one equation. From here you will get x of t, from here you will get t of t, and after using initial condition you will get the expression for xa and xb like this. From first expression you can get where x is from a to b, some a to b, and for second expression you will get this where t greater than 0. Okay, now the boundary condition is, you can apply boundary condition. Suppose a boundary condition is given, u a comma t is 0, b comma t, some expression or boundary condition is given 0, and you can apply. From here what will be the value of, fine, that imply x of a is equals to 0, and from here you will learn these things, you know, maybe in your next lecture. So now you can use this expression with this condition, and you can get the value. After for given any type of boundary condition, you can put the value and you will get the expression. You will get the value of ux comma t with the help of capital X and capital T. Because of variable separable, you have to solve separately x and the expression for t also. Then you can product those two expression and you can get the answer. Please try in this way, try to solve in this way, uh, then you can get the answer. Is it fine?
Okay, ma'am. I will be trying.
You will also learn these things in your upcoming lecture series, so don't worry about this.
But is given, madam.
Okay, assignment. Is there any assignment? Okay, you can send me the problem. I will
Okay.
give you the solution for your any one of questions.
Sure, ma'am. Sure.
Okay, that's all from my side. If you have any other doubt, you can ask. Otherwise, we can leave. Is there any doubt in this session?
No, ma'am.
Okay, thank you. Thank you, everyone.
Thank you.